Okay, let's get started. Thanks for joining us today. Today we will be walking through switchback testing for decision models. I'm your host for today, and we have Dirk and Nicole from the Nextmove engineering team who will be your presenters. Nicole's going to walk us through a quick orientation to the Nextmove platform, and then we'll hop right into the testing suite for decision models. So why is testing critical, and how do we think about it at Nextmove? Then we will jump into switchback testing itself. So we'll start off with talking about a description of what it is, when to use it, and then Dirk will lead us through a demo of switchback testing on the Nexus platform. So throughout the presentation, please feel free to ask questions. You can ask those directly in the chat or using the Q&A feature that's built into the platform as well. We will monitor both and look forward to a great discussion with you. So with that, I will hand it over to you, Nicole, to start us off.
Thanks, Renu. As Renu mentioned, I'm going to be starting by giving an overview of the Nextmove Decision Ops platform. So what you're seeing here is a visual of where Nextmove sits in the broader ecosystem. Nextmove takes in various data sources like platform data, operational data, predictions, and business rules, and it outputs results to ops tools and customer applications. So within Nextmove, we have different layers to the platform. So at the top layer, we have vertical specific applications like routing, shift scheduling, and bin packing. And then a layer below that is the optimization technology like modeling languages and solvers. So at Nextmove, we have our own modeling language and solver. We also support Pyomo, Highs, and OR tools, and we're constantly adding to this list. So if you don't see something on here that you use, give us a shout. We also have at the next layer various languages that we support. We support Python, Go, and Java. And then below that is the infrastructure and ops layer. This allows you to run applications on the Nextmove cloud, run experiments, and integrate with your CI/CD workflows. And in order to interact with our platform, we have various interfaces for you to make use of. We have a command line interface, Go and Python SDK, and the Nextmove console, which is sort of the hub of the platform. So now that we've talked about the Decision Ops platform, let's dive a little bit into testing. What is decision model testing? Well, it's a set of techniques that reduces risk and builds confidence in the decision modeler's workflow. And in doing this, you can achieve stakeholder buy-in and drive improving solutions. Why does decision model testing matter? Well, mistakes are expensive, especially in a production environment, and the tolerance for error is low. And so using decision model testing helps you to mitigate the risk of deploying big mistakes in production. Teams also need a clear, repeatable path to production. They need to know when they want to get their decision model out into production that there's these 4 or 5 gates that they have to pass in order to feel confident pushing that up into a production environment. And in that same vein, your stakeholders require confidence in outcomes. And so giving them a set of criteria for what you've tested to be able to move into production is important. So this quote is taken from the Principles of Chaos Engineering, which was coined by Netflix. And I'm just going to pull out this last piece of the quote here. Chaos strongly prefers to experiment directly on production traffic. At Nextmove, we think of production testing as the holy grail of your decision model testing, but it's not where you go to first. You have to go through a few more gates before you could feel confident to test directly on production traffic, because as I mentioned, it is expensive if you make a mistake. So now I'm going to go into how we think about testing and how we set up a workflow for getting up to that point of testing in a production environment. So at Nextmove, we think about decision model testing with this framework. So we bucket our tests into 2 categories. One is production testing. This is essentially your go, no-go gate for production rollout. These are things like shadow testing and switchback testing, which is the focus of this talk. Now we move into historical testing. These are the kinds of tests that probably most people are familiar with, where you're testing on a sample of historical inputs, things like batch experiments, acceptance testing, and so on. Regardless of whether you're looking at production tests or historical tests, you want to do these in a systematic and repeatable way. You're likely doing this as part of a CI/CD workflow. So to do that, we've introduced these little components or Lego pieces that kind of come together to allow you to quickly apply historical tests or production tests. Things like input sets, model management and sharing of results, run history, observability, and so on. So now how do they all fit together into a workflow? We were inspired heavily by the Git flow. I'm sure most people have seen this visual from Atlassian, just demonstrates the process of working on a code base with version control. So now we move into the decision ops workflow that we think about here at NextMove. And so let's start at the bottom layer, which is model code. Looks very similar to the Git flow diagram I just showed, where you have a decision modeler that's branching off of their baseline decision model code base. They're working on a feature in a candidate branch. And now at this point, this is a perfect time to introduce batch experiments. Batch experiments are sort of like exploratory data analysis where you're not exactly sure what you're looking for, but you're working on a code change and you just want to look at the impact on a set of historical data. You might run batch experiments a few times as you're iterating through your development on this candidate branch. And now when you're ready to push up those changes and merge them into your baseline branch, this is a perfect time to run acceptance tests. And acceptance tests are sort of a more targeted kind of test where you have a hypothesis or a set of criteria that need to be met in order for you to accept that model change. And so this is kind of a go or no go decision on merging your code. And so let's say you pass that gate. Now you've merged your code, but that isn't the end of the story because now you have to get that candidate branch up into your operational environment. And so to do that, you need to push that candidate branch up into your model API layer. But you don't just want to push it up and turn it on and cross your fingers and hope it works. You can push it up into your model API layer and have it running in shadow mode next to your baseline branch or your baseline code. And when it's running in shadow mode, it's not actually making any decisions, but you're allowing it to test itself on out of sample data, on production data that it hasn't seen before, which is really valuable. You can look at things like error rates and so on. Let's say you pass that gate. Now the next gate is the focus of this talk, which is switchback testing. Switchback testing is where you're alternating randomly between your baseline and your candidate branch, similar to A/B testing for decision models. And this allows your candidate model to actually operate in your operational environment in a controlled test. And so we'll talk a bit more about what switchback testing is in a minute. But ultimately, what that unlocks for you is the ability to confidently roll out your candidate model everywhere because you've passed all of these different gates in your development workflow. So let's drill in a little bit to switchback testing. What is it? Well, as I mentioned, it compares a candidate model to a baseline model in a real operational environment where you're allowing both to make decisions out in the wild. And it does so in an A/B test-like way where you're randomizing which model is applied. But at this point, it's not randomizing its application to an individual vehicle or an individual stop. It's randomizing it to units of time and or location. And in doing this, we can mitigate the network effects that can happen in problems like routing or really just generally multi-sided marketplace problems. And so we dropped this last tidbit in just because we thought it was interesting and because DoorDash references it in their articles that we were heavily inspired by. So originally, switchback testing was leveraged for cow lactation experiments to reduce the variance from the cow effect because different cows have essentially different baseline yields that didn't matter. It didn't matter what feed they were given or what treatment they were given. And so switchback testing allows you to test kind of different treatments on the same cow to reduce that variance. And so what does switchback testing look like at NextMove? This is a visual that shows how, let's imagine this is for one region. We take that region and we split up time in advance and generate a plan that the switchback experiment will follow. And so in this case, our plan units are 1 hour increments. And for each 1 hour increment, we randomly assign that plan unit to either the baseline or control group or the candidate group. And you can see, since it's random, you can have multiple plan units in a row that are the same treatment or the same control, but the same treatment, but that's just part of the random nature of this experiment. And so a common question that we get asked at Next Move is when you should use switchback testing. So starting out, you can ask yourself, are your KPIs external to the optimization? If the answer is no, then you would be perfectly fine to run a shadow test because you can get all of your KPIs directly from your optimization output files. And you don't need to actually make operational decisions to really understand the impact on your KPIs. That's not super typical. Usually you would have some external KPIs. For example, in routing, driver acceptance rates or customer retention, things like that, where you can't learn those things just from running on historical data or running in shadow mode. You have to make decisions to learn about those things because they're behavioral. So assuming that you have some external KPIs, some behavioral KPIs that you care about, then you move to the next question, which is, are your KPIs independent across your treatment groups? And so what I mean here is if we think about advertising, for example, if you have a treatment and a control group in an advertising problem, your treatment, if you show your treatment group campaign A and you show your control group campaign B, what you show your treatment group has no impact. It's independent of what happens in your control group. The KPIs are independent between those two groups. But in a routing problem, that's not the case. And we're going to touch on that in a minute. But basically, we think about this as network effects, where you don't have a proper separation between your treatment and control groups. And this is very common in multi-sided marketplace problems. And if this is the situation, then you would definitely want to do a switchback test for your production testing. So now let's talk a little bit more about network effects. Network effects occur when an application of a treatment impacts both your treatment and control groups. So an example of this is if you were changing the way that you assign drivers to orders through, say, a new objective function, that change impacts drivers and data in both your treatment and control group because drivers are a shared resource across that whole ecosystem. And so what are some examples in which switchback testing makes sense besides routing? You also have order fulfillment. So these are problems where you're trying to figure out which warehouse do you source items from and what fleet do you use to do that sourcing. And so if you were exploring different models around order fulfillment, this would be a perfect scenario where you would want to do switchback testing. Incentive allocation. So how do you encourage drivers to come online during undersupply periods? And then also shift scheduling. So how do you schedule your workers to minimize no-show rates? All of these examples are examples of running a multi-sided marketplace. And also all of these examples have behavioral KPIs that you can only learn from making an operational decision. So now I am going to turn it over to my colleague Dirk to give an overview of the demo and then jump right into console.
Well, yeah, thanks, Nicole. So for our quick demo here, we have a hypothetical scenario which involves our demo company, the FarmShare company. And the FarmShare company delivers goods from farms to consumers that would like to buy these goods. And we have a routing model in production there that clusters stops into neighborhoods. And we also have a staging model where we explored the dropping a constraint and dropping that neighboring compatibility attributes constraint. And we did some shadow tests, and it showed that that substantially reduces the number of unplanned stops. So we would like to launch a switchback test to actually see how that works, and in particular observe indicators outside of the system. like driver happiness or the duration of the delivery. Now I'm going to share my screen. Um, so here I'm in the Nextmove console. Within the Nextmove FarmShare team, there are a number of apps. One of these apps is our delivery routing application. And what you see, and we look at switchback tests, let me show you some key concepts here. So when you click on an app, you see some like general information around it. An app has a number of instances. So here we have a production instance and a staging instance. And you can think of instances as the components that answer your optimization requests. So in this case, they make a routing decision. They do that by executing some model or your code, and your code is called a version, and they're here. So a version is essentially your code with an ID. So different different instances can execute different versions, and we have our production instance here, among others, that executes our old routing model, and then we have a staging instance that executes a new routing model with the attributes disabled. And then we also have a number of runs. You can take a look at all the runs that were made within the application. There are a bunch of experiments, and then we also have a big HTTP-based API that you can also use programmatically. So within experiments, and this is a demo account, so there are a lot of experiments here already. We have many types of experiments, and what we're going to show today is switchback here. So let me first walk you through how you create a switchback test, and then we look at an already completed one. So it's relatively easy. You just click on new switchback test. You give it a name, switchback demo, for example. You can give it a description. You then select the baseline instance. In this case, that's production. So every run that's being sent to our production instance now triggers potentially a switch and might be answered by the candidate instance, and our candidate instance is the staging one. And let's say we wanted to run the switchback test over a week with a unit duration of 60 minutes. So we could say, let's run it for 40 units times 60 minutes is roughly a week, and we'll let it begin next Monday. So if I now create in a draft mode, well, that already exists. Let's give it some number. 43. There we go. Now this is in draft mode. It hasn't been started, but it has already this central component called the plan. And you can already see how this switchback test will execute itself. For the first 4 hours, the staging instance will answer the run request, and the production, and you see the random nature here. And in the limit, it will be like a 50-50 split right now. And but we're not going to run it because it just takes some time and some real input, but we have one prepared. And this one is a bit special. That just ran for a few minutes, and I set the unit duration to 1 minute. So that switched like every minute the underlying model. And what we give you when such an experiment is done, we give you a basic summary and of course all the raw data that you can use then to further analyze your experiment. There are a number of indicators here. One group is there by default, like the value of your optimization model or the duration. And then we also support a bunch of custom domain-specific indicators. That's usually decided by your application. And in our case, that's unplanned stops here. And we see this switchback experiment that had 11 production runs and 5 staging runs during that period of time. And we see, okay, indeed, the unplanned stop, the number of unplanned stops also decreased here. But most importantly, you'll get all the runs that happen during that period of time. And each run here is also associated to the specific plan unit. So you can take that, you can either download it as a CSV, or even better, you use our JSON endpoint to query all the runs, load it into your favorite statistical software package, use Python or R or Julia, and yeah, associate the runs that you saw to your external indicators that are not yet in the Nextmove platform. And then you'll find out if driver happiness increased or decreased, or if there have been any problems in delivery times. Yeah, that's the quick demo, and then back to you, Nicole.
All right, so what just happened? Well, Dirk created a switchback test in the Nextmove console, and then he reviewed the plan in a draft state, and then he opened up a previously run switchback test since they take a little time to run, and went through the results there. He did identify from inside the system that there were fewer unplanned stops in the candidate model. And he also identified that there's a next step, which we didn't go through on this call, but the next step would be to analyze your operational impacts, those behavioral metrics that we talked about earlier, things like driver happiness or acceptance rates. We wanted to briefly touch on some considerations when running a switchback test. It's important that you're aware of carryover effects in a switchback experiment. So, for example, let's say at 9 a.m. Model 1 switches on, and then 9:10, you have an order entering the system. Model 2 switches on in the switchback at 9:45, but your order isn't delivered until 10. So in this situation, this order is touched by both treatments. And so it's kind of in this spillover period in the switchback test. And so some practitioners will assume there's no carryover effects and just move on with the analysis, while others will remove that data completely if it falls in that spillover period and only look at sort of clean orders, if you will. Some practitioners will even use optimization models to optimally design their switchback experiments and minimize that spillover period. And so that's something, we'll send a paper on that after this call. That's something that we find very interesting because you could even host that model in the Nextmove platform. It's also important to select your plan units carefully. This relates to the previous point. If your average delivery times are 45 minutes, it wouldn't make sense to do a switchback period of 10 because all of your data would end up in that spillover territory and it would be kind of convoluted to understand the treatment effect. So we are very excited to offer switchback testing here. It's typically an industry standard when you're looking at multi-sided marketplaces, and we have plans to continue adding functionality that helps to use these switchback tests in meaningful ways. We were heavily influenced by some academic papers that we plan to share after this call, as well as some blog posts, for example, from DoorDash, who are definitely pioneers in the field of applying switchback to marketplace problems. So cheers to all the statisticians that are here right now and anyone who's going to be watching this video. It's certainly complex to do these kinds of tests in an operational environment, and we hope that this is somewhat helpful in your analysis there. So we hope that after listening to this talk, you've gathered that testing for decision models is critical and challenging, and that switchback tests can help you to understand the real-world impacts of your decision model changes in an operational environment, and that switchback testing is one piece of the decision ops workflow that contributes to a clear and repeatable path for moving your code into a production environment. Now I believe we have some time for Q&A.
Yes, thank you so much, Nicole and Dirk. That was a wonderful presentation. Let's see. It looks like we have one question that's come in. The question is, are you planning to support the analysis of external KPIs on your platform?
I can take that one. We do plan to support that in the future. That is on the roadmap. In the short term, one thing that we're doing is we're enabling the ability to push up external metrics into the Nextmove platform. So that's kind of the first piece, is actually having a connection between your external metrics that we don't know about and the next move platform. And then once we have that, we can do some exciting things on the analysis side. And again, we've been reading a lot about this with some of the papers that we'll be sharing out soon.
Perfect. And for anybody whose question we were not able to get to today, don't worry, we will absolutely be reaching out after the presentation to further have more discussion on switchback testing in general and any specific questions as well. So thank you for your engagement. So what to do next? Please go and start a Next Move account. It's free and you can go ahead and dive right into testing. Talk with our team. As you can tell, we enjoy talking about all things optimization. So we are always here for more questions and discussion. And then head over to our website for more content around testing, around decision platforms, CI/CD, and more. So there are blogs and videos, and of course, our wonderful documentation. So with that, we will end the presentation for today, and we hope to see you next time. Thank you.